Hello everybody, welcome back. This is section 5.3. It's called the other 4 trig functions, but we'll put all 6 together. There's 6 trig functions in all, and we already know by definition on a unit circle the sine of an angle is y, the cosine of an angle is x. We already talked about that. Now we want to define tangent of an angle is y over x, which by the way is sine over cosine. We want to define cosecant of a theta is 1 over y, which by the way is 1 over sine. And we want to define secant of theta is 1 over x, and which by the way is 1 over cosine. So these are all just definitions of the six trig functions. So we'll get to that board in a second, but just for an example, so suppose there's a unit circle, and a point on the unit circle is, say, x is a half, and y is a square root of 3 over 2. And that's a point on the unit circle. This squared plus this squared is 1. I will guarantee that. So it's a point on the unit circle. Here's theta. And so we just want to, what are the trig functions? What are the 6 trig functions? Okay, well, 1, sine of theta is y, square root of 3 over 2. Cosine of theta is x, 1/2. The third trig function is tangent. The way we're listing it, tangent of theta is y over x, square root of 3 over 2 over 1/2. And if you flip, you'll find this is just the square root of 3. The cosecant sine. I'm going to erase the cosine. Cosecant of x is of theta is 1 over y, which is 2 over the square root of 3, and that's fine, by the way, because you have calculators. But this turns into 2 times the square root of 3 over 3. The secant of theta is defined as 1 over x is 2. Remember, cosine here was a half. Tangent, the tangent we already had was the square root of 3. So the cotangent of theta is 1 over the square root of 3, with the square root of 3 over 3. All I'm doing is working with sine and cosine and deriving all 6 from there. And that's what this whole section pretty much is about. So now let's go to the table on page 475. We started this in class last week. I may have referred to it on the video. And so this is the first quadrant. The special angles in the first quadrant. 0, 30, 30, 60, 90 is a triangle. 45, 45, 90 is a triangle. So these are the special angles in the first quadrant. And we've done this. Sine of 0 is 0, sine of pi over 6 is a half, sine of pi over 4, square root of 2 over 2, sine of pi over 3 is a square root of 3 over 2, and sine of pi over 2 is 1. Cosine of each one of these. 1 square root of 3 over 2, square root of 2 over 2, 1/2, and 0. That's the sine and cosine. That we've had in class already. Now let's do the tangent. Let's do the tangent. The tangent is actually y over x. 1/2 over the square root of 3 over 2 turns out to be the square root of 3 over 3. All I'm doing is putting this one over this one. This one over this one is 1. Square root of 3 divided by a half, square root of 3 over 2 divided by a half is just the square root of 3. 1 divided by 0, hey, undefined. It's going to happen 3 times in this chart. So now let's go to cosecant. Cosecant is 1 over the sine. Right here's the sine, so I'm just flipping all of those. Check it out. The cosecant of 0, can't do it. Cosecant of 30 degrees, pi over 6, is 2. This is this is 2 divided by the square root of 2, or square root of 2. I'm flipping this right here. 2 divided by the square root of 3 is 2 times root 3 over 3. You can check that out yourself. And I'm flipping this 1. Secant, again, is, now we're looking at cosine right here, and we're going to flip all those. With the secant of 0 is 1. All I'm doing is turning this upside down. 2 root 3 over 3. Square root of 2 over 2. 2 divided by the square root of 2 is square root of 2. The secant of 60 degrees is just a plain 2, and then this is going to have to be undefined because we're flipping the 0. Tangent. Tangent is equal to y over x. Cotangent is equal to x over y. It's just backwards. So I'm just flipping this for the cotangent. That's undefined. 3 times, this is the square root of 3. That's 1. This is 1 over the square root of 3, which turns into the square root of 3 over 3. I'm flipping that. That's 1. I mean, you can't flip infinity. But, okay, so there's a chart. If you remember that, or make it yourself and paste it on the front of your book, or you can always look things in Trig up. But that is really nice to have, because then what you do is you can extend that to other quadrants using the reference angles. Extension to other quadrants. Using reference angles. Here you go. This is the mnemonic device. In the first quadrant, all 6 trig functions are positive. And then, so what we want to do is remember that over here in the second quadrant, remember this is x, y, the x is negative. The y is positive. So if y is positive, that's sine. So sine is positive in the second quadrant. So is, because they are reciprocals of one another, so is cosecant. In the third quadrant, because this is xy, x and y are both negative, and if you divide them, you get a positive number, and that's what tangent is, dividing x and y. So tangent is positive here with its reciprocal function cotangent, and then in the fourth quadrant, because x is positive and y is negative, the cosine is positive, and it's Pythagorean function is the secant. So the way we try to remember this is all S, T, C, and we make up all these mnemonic devices for A, S, T, C. I learned at Albany State Teachers College. I don't have any idea why that existed, but people think all scholars take calculus. The book uses a smart trig class, something like that. And one of my students, one of my students in high school several years ago, smart Alec, made another stupid trig class. It's like, oh, come on, man. Anyway, yeah. So how this works is, suppose, I'm going to erase this table, again, page 475. Suppose, let's see, sine of theta is 3/5. And theta is in quadrant, let's just go with 1. first off. And then I'm going to do another one of these, and this is going to actually turn out pretty nicely because of the Pythagorean Theorem. And so what the question is, what's the other 6? The other 5 of the trig functions, 5. Okay. Well, so we want to do something like this. Sine, that's 3/5. We have that. We want a cosine. We don't know what that is. We want a tangent. We're not going to know what that is. Then over here will be a cosecant. By the way, that's 5/3. It's upside down. I mean flipped. Secant, we don't know what that is, and cotangent. We don't know what that is. So that's what we wanted to find out, what all those are. Pythagorean Theorem. Because sine squared plus cosine squared is 1. That means 3/5 squared plus cosine squared is 1. 9 25ths, subtract from 1. Cosine squared is 16 25ths. Cosine is plus and minus 4/5. Right here, it says it's plus. So now we have the sine and we have the cosine. This is 4/5. Tangent is going to be 3/5 divided by 4/5, or 3/4. Cosecant, we're just flipping these. This is 5/4. This is 4/3. And so those are the problems we're going to be asking from this particular section. We're going to pick it up again, and we didn't quite finish this section, but it's just identities, and then we're going to do the next section, which is going to be right triangle trigonometry. But I just want to point out to you a piece of, this comes from last year's calculus book. Every single calculus book in its right will have a page like this in the very front, in the front cover, the back cover. So much in trigonometry, you just look it up. We're going to talk about some of these identities, but there they are for you, forever are. By the way, the other side is calculus formulas. I mean, you're going to look up a lot of calculus formulas too. These integration, there's millions of those. So good luck with that. This is, again, pre-calculus. Hey, talk to you soon.